Okay, guys, this is the first video about projectile motion. So we're going to be looking at horizontal projectiles now. So we are on page 2. And if you look at this picture here, the height is 5 meters, and the horizontal distance traveled is 20 meters. And we're trying to find the speed, the pitch and speed. So in order to do that, we have to start working in the x direction. So he fires this way with an initial velocity VO. And that's delta x. That's the horizontal distance traveled over time. Now, this is 20 over time. Now, we don't know the time, but we know that the vertical distance is 5 meters. So we have to use the vertical motion equations to figure this out. So we're going to use delta y is 1/2 gt squared, because the initial velocity in the y direction is 0. So this is going to be -5t squared equals -5. So t is equal to 1. So this is 20 meters per second. Or you should have realized that after 1 second, an object will drop 5 meters. A cannonball is fired horizontally at 10 meters per second from a cliff. Its speed after 1 second, is about, so we're going to try to find the speed after 1 second. So after 1 second, horizontally, it's going at 10 meters per second. But after 1 second, it gained, based on the acceleration of -10 meters per second squared, it picked up 10 meters per second down. So in terms of magnitude, it's 10 meters per second. So it's going 10 meters per second horizontally, it's going 10 meters per second vertically. You want to find this resultant here, which is 10 radical 2, which turns out to be about 14 meters per second. All right, the next page. So for the next page, we're trying to sketch the horizontal velocity. So horizontally, rock A is going at a constant speed. Rock B is also going at a constant speed, but it has to be a higher constant speed because it travels a longer horizontal distance. So it had to be thrown with more horizontal speed. The vertical velocity has to be negative because when you're going down, it's all negative, right? And it has to be increasing in the negative direction. And it's the same for both of these graphs because they're both dropped from the same place. It doesn't matter where they dropped from, but they're both going to have an increasing velocity. Okay. So these two lines down there should be parallel. If we look at RT2, okay, after you read it, of course, it says to rank the time it takes the bullet to hit the ground. So now, the time it takes the bullet to hit the ground when you fire in something horizontally, the only thing that really matters is how high above the ground it is. So the higher above the ground it is, the more time it's going to spend in the air. So the order should be B and C, okay, should be spending more time in the air because they're higher. Then comes D, then comes A. Okay. All right. The next one is you fire in something at an angle. I know we haven't done anything at an angle yet, but we can still answer the question. It says to rank the acceleration of the cannonballs when they reach their highest point. When they're at the highest point, the only thing acting on them, not just at the highest point, anywhere, is just the force of gravity, which means the only acceleration they're going to have at the highest point is the acceleration of gravity. So in all cases, regardless of the initial speed, regardless of their mass, they're all going to have the same speed. And you're going to explain your reasoning based on what I'm talking about. Okay. All right. Number 1 on page 4. So this height here is 39.2 meters. But in terms of displacement, is negative 39.2. This horizontal distance is 42 meters. Okay, and we're trying to find with what speed. We're trying to find the initial velocity. So if I want to find the initial velocity, I have to start with the horizontal stuff. Okay, so I think the 39.2 only stops here. Yeah. Okay. So V0 equals delta x over time. Okay, which is equal to 42 over time. Now, if you don't have time, you have to go to the y direction and get the time. So the equation you're going to use most of the time is delta y equals 1/2 gt squared. Keep in mind that the v initial in the y direction is 0. So this is going to be negative 39.2 equals negative 5 t squared. And you get a time equal to 2.8 seconds. And you should get an answer of 15 meters per second. All right, number 2. A plane flying horizontally in altitude of 500 meters and a velocity of 220 meters per second east dumps an empty gasoline, I think it says tank here. Yeah. Ignore air resistance. How long will the tank take to fall to the ground? Okay. So we're trying to find the time. So we know the initial velocity in the horizontal direction. So we're trying to find the time here. So I can swap this too. So the time here, the V0 here, that's equal to, so I don't think I have the delta x. So maybe I have to use some other equation. And I know the height. So maybe I have to use delta y equals 1/2 gt squared. So this is negative 500 equals negative 5 t squared. So it's going to take 10 seconds for it to hit the ground. And then how far out? So we just have to come back to the horizontal direction and find out what delta x is. So this is 220 equals delta x over 10, and you should get 2200 meters. Okay. All right. The next one says a stone is thrown horizontally at 15 meters per second. It is thrown from the top of a cliff that is 45 meters high. How long does it take the stone to reach the bottom of the cliff? Now, if you remember your numbers, your heights, after 1 second you drop 5 meters, 2 seconds 20, 3 seconds 45, 4 seconds 80, 5 seconds 125. If you don't remember that, we can try solving the equation for the time. So since the horizontal velocity is 0, this is what your displacement formula looks like. So this is negative 45, because it's going below your origin. It's negative 5t squared. So the time is 3 seconds. How far from the base of the cliff? So we have to work with the horizontal stuff. Okay, so this is 15 delta x over 3. So it should be 45 meters. What is the velocity of the stone at the time of impact? Now, at the time of impact, two things are happening. You're going at 15 meters per second horizontally. That doesn't change, never changes. Okay, and vertically, you can figure out how fast you're going by using an equation, or we can come back and do it conceptually. So I think we have to use Vf squared, this is in the y direction, equals V0 in the y direction squared plus 2g delta y. Now, initially, there is nothing in the y direction, no velocity. So Vfy squared equals negative 10 times negative 45. Okay, so this is going to be a radical of 450. But you have to say plus or minus. And since you're going down, it should be the minus answer. So okay. No, I'm sorry, this is 20. Yeah, this is 20. So this should be 900. So this is negative 30. So the VFY is negative 30 after 3 seconds. Now we could have done that without doing all this math, because we know that it drops for 3 seconds, and every second is going to pick up an extra 3 meters per second every second in the negative direction. So this is in 30 meters per second in magnitude, and all you have to do is find out what this resultant here is. So the V is equal to, you can do a Pythagorean theorem, so 33.54 meters per second, and we have to figure out what this angle here. So you can do an inverse tangent of 30 over 15, and you should get about 63 degrees. Now that's below the horizontal. You have to write that. Below the horizontal. All right. Let's look at number 4. Okay. A baseball is thrown from the roof of a building at 20 meters per second in a horizontal direction. It strikes the ground 2.8 seconds later. Find how far from the building the baseball lands. So I think we can just do V initial equals delta x over time. And we can just plug in 20 for the velocity, plug in 2.8 for the time, and find out what delta x is. So delta x should be 56 meters. For part B, we're trying to find the height of the building, so delta y. So we're going to find the displacement and just take the positive value of that to get the height. Is 1/2 gt squared, negative 5 times 2.8 squared, and you should get negative 39.2. So in terms of height, it's just positive 39.2. You see, all these problems are pretty much similar. Now, number 5. A stone is thrown horizontally at a speed of 10 meters per second from the top of a cliff that's 80 meters high. Now, just looking at the 80, you know that this is going to spend 4 seconds in the air. How long does it take the stone to reach the bottom of the cliff? Well, we know it's 4 seconds, but let's see how we can do the math. So we have to use this equation here and get the time. So this is negative 80 is negative 5t squared. Now, if you do the math here, you should get 4 seconds. A lot of times people don't put a negative here, and they get a time that's going to be the square root of a negative number, and they kind of like just ignore that, thinking that nobody will see it, but I will see it. Okay, how far from the base of the cliff would it strike? So we're looking for delta x. So V0 equals delta x over time. So this is 20 delta x over 4, and you should get 80 meters. I'm sorry, I'm looking at the wrong one. 10. This is 10. Yeah, I'm working on number 5. All right, let's look at number 6. So now they're giving us the height, they're giving us the initial velocity. It says how long does it take. So we don't know how far out it lands, so we're going to have to work with the y direction. Now delta y is negative 2,000. This is negative 5t squared. So t should be about 20 seconds. Yeah, square root of 400. How far from the ship? So we're going to have to do V0 equals delta x over t, and we have to find delta x. So this is 90 equals delta x over 20, and that should be 1,800 meters. See, they are pretty straightforward. They're pretty quick. All right, let's look at number 7. At a height of 784 meters, a skydiver drops a flare from a plane flying horizontally at 30 meters per second. What horizontal distance does the flare travel before striking the ground? All right, so we're looking for delta x. So I'm going to start, I'm doing this up here. with the equation in the x direction, my initial velocity is 30 equals delta x over t. Now, I don't have time, so I'm going to rely on the height to get the time. So I'm going to say delta y is 1/2 gt squared, negative 784 equals negative 5t squared. You get t equals t equals 12.52 seconds. You put that in here, and you can find a delta x equals to 375.66. All right, let's go to number 8. A tiger leaps from a 7.3 meter high rock, so delta y is negative 7.3, with a speed of 7 meters per second. How far from the base of the rock will it land? So again, V0 is delta x over time. This is 7 equals delta x over, we don't know the time, so we have to go to the other side, to the the vertical direction, and get the time. So this is negative 7.3 equals negative 5 t squared, and we should get a t equal to 1.21 seconds. So you just put that in here, and you should get a delta x equals to, that's equal to 8.46. All right, next one. A bolt run horizontally at a speed of 18 meters per second from the roof of a building lands 24 meters from the base. So delta x is that. How high is the building? So basically we're looking for delta y, negative 5. Now I need the time. So I'm going to get the time from the x direction. Okay, so this is going to be 18 equals 24 over t. So t is 24 over 18, which is 1 1/3. And all you have to do is put that in here and square it, of course. Okay, and you should get about 8.89 meters. So you're going to get a negative, but since it's asking how high is the building, you have to kind of give the positive answer. Okay. A diver wants to jump from a 20-meter high cliff. So the delta y is negative 20. The rocks at the base of the cliff project outward 7 meters. So delta x is 7 meters. So delta y is the negative 20. Delta x is positive 7. With what minimum speed should he run so that he clears the rock? So we're looking for speed. So V0 equals delta x over t. And that should be equal to 7 over the time. So now you go to delta y is 1/2 gt squared. Get the time, come back and put it in here. So this is negative 20. And you should know that it's going to stay 4 seconds in the air because of that 20. Negative 5 t squared. No, not 4 seconds, 2 seconds. What am I saying? 4 seconds, it will be at the 80-meter mark. So this is 2, and it should be 3.5. All right, let's look at this problem here. And maybe I'll just explain this. And you can write the explanation, what it says to explain. A toy truck is launched horizontally from a table of height h. In case A, the toy truck leaves this table with a speed of v. And in case B, the toy truck leaves the table with 2v. Okay, so this is a statement we have to figure out whether it's right or wrong. The faster you go, the less time it takes to get there. The truck in case A will be in the air longer. Well, that would be true if the horizontal distance was the same. But the truck that's going at 2v is going to land further out. Okay? But since they both launched from the same height, the only thing that really matters is the height. So they're going to be in the air for the same amount of time, regardless of with what horizontal speed they're going to have. So in horizontal motion, the only thing that matters really, the amount of time spent in the air, is how high above the ground you are. Okay. All right. So now we're going to figure out which one is going to spend more time in the air. Now the initial velocity is not important. Their masses are not important. The only thing that matters is how high above the ground they're going to be traveling from. They're going to be flying from. So the second one, car B, is 80 centimeters above the ground, which is higher than 50. So car B is going to spend more time in the air. So which means car A is going to spend less time. All right, last page. All right, two identical rocks are thrown horizontally from a cliff with different velocities. Okay, so you can see that B had to be thrown with a higher velocity because its range, its horizontal distance is bigger. The rocks are thrown at the same time and are shown below while they are still in the air after a few seconds. Okay, so now here you can see that they are at the same height. Okay, they drop in the same distance in equal amounts of time. Will the magnitude of the horizontal velocity of car A be greater, less than, or equal to that of car B? Well, I mean not car, rock B. Rock B had to be thrown with a higher speed because its horizontal distance is bigger. The next question is, will the magnitude of the vertical velocity of car A be greater than, less than, or equal to the magnitude of the velocity of rock B? They're going to have the same vertical velocity because they are at the same height and they dropped for the same amount of time, right? So they increased their speed by the same amount of time vertically. Part C, will the magnitude of the horizontal acceleration of rock A be greater than, less than, or equal to the magnitude of the horizontal acceleration of rock B? Well, actually, they're going to be, the accelerations will be equal in the horizontal direction, and they will be equal to 0 because they're both going at a constant velocity. Even though B is going at a higher velocity, but it's still constant. And part D is, will the magnitude of the vertical acceleration of rock A be greater than, less than, or equal to the magnitude of the vertical acceleration of rock B? Well, as they're falling, the only force acting on them vertically is the force of gravity, right? So they should have the same vertical acceleration as they're falling. And that's the acceleration of gravity, which is negative 10 meters per second square in the absence of air resistance. And that should do it. All right, I'm out. Peace.